Hello and welcome to Spy Math. This is Mr. Spy, and this will be part 3 of the June 2018 Geometry Regents questions 32 through 34. Let's just have a quick introduction to part 3. Part 3 is 3 questions, usually a coordinate geometry proof or regular proof, a volume question, and a trigonometry question. In this case, our first question is a coordinate geometry question. Let's move over to it, question 32, and let's begin. Part 3, question 32. Triangle ABC has coordinates A at -1, -1, B at 4, 0, and C at 0, 4. Prove that triangle ABC is an isosceles triangle, but not an equilateral triangle. So the first thing we do, before I plan our plan, is draw a triangle, so you don't have to do. So if you draw a triangle wrong, be very careful, you will lose points. A at -1, -1, B at 4, 0, and C at 0, 4. Our plan is to show that two sides of triangle ABC are equal, and the third side is not equal to the other two sides. So we're going to use a distance formula 3 times to find the distance of each of the 3 sides. So you first find the distance of AB, 4 minus -1 squared plus 0 minus -1 squared equals 5 squared plus 1 squared, which equals the square root of 25 plus 1 equals the square root of 26. So a little bit more than 5. Then we find the length of BC, 0 minus 4 squared plus 4 minus 0 squared, -4 squared plus 4 squared, 16 plus 16, the square root of 16 plus 16, the square root of 32, which is something about 5.5, 5.6, don't really matter. So you just want to find two sides the same, so AB is not the same as BC. Now the length of AC is the square root of 0 minus -1 squared plus 4 minus -1 squared, which is 1 squared plus 5 squared. 1 squared is 1, 5 squared is 25. 1 plus 25 is 26, so square root of 26, which is the same length as AB. So AB is the same as AC. Then you have to write a statement at the end, which our conclusion is triangle ABC is isosceles since AB is equal to AC, and not equilateral. Let me fix the spelling of that. And not equilateral since segment BC is not equal to AB. Therefore, triangle ABC is an isosceles triangle. It has 2 equal sides, but not equilateral. I misspelled again. It's not all 3 sides of the triangle equal. When you do this, you must define both terms. In this case, you got to define the term isosceles and define the term equilateral in the terms of sides, not angles. That's what we use to prove the triangle was isosceles and not equilateral. You have to get both parts to get all 4 points. Now on to question 33, the trigonometry question. The map of a campground is shown below. Campsite C, first aid station F, and supply station S lie along the path. Path from the supply station to tower T is perpendicular to the path from the supply station to the campsite. The length of FS, segment FS is 400 feet. Angle formed by TF and path SS is 72 degrees. The formed path by TC and path CS is 55 degrees. So we want to find what? To determine and state to the nearest foot the distance from the campsite to the tower. So the first thing you need to check is that all our units are in feet. So 400 feet. And we want our answer in feet. We let T be X. Let ST be Y. You need two trigonometric formulas working from the triangle TSF, and then expanding that to triangle TSC. So let's first find the length of ST, where the tangent of 72 degrees equals Y over 400. Cross multiply. Y equals 400 times tangent 72, which is 1,231.07 feet. Let's confirm that on the calculator. So we want to confirm on our calculator that 400 tangent 72. So we go to mode, make sure we're in degrees. Good. So you do 400 times tangent 72. And you get 1231.07 round to the nearest hundredth. Because you want your answer to the nearest foot, you really want to keep units e to the nearest tenth to the nearest hundredth. Then you find the length of CT, which we called x. Find that by using sine of 55 degrees equals the length we just find, 1231.07 over x. Anytime x is in the denominator, you divide. So 1231.07 divided by sine 55. So in this case, we're going to just put the answer in. Just want to keep it to whole. Divided by our sine of 55 degrees. And we get approximately 1502.86 feet, rounded to the nearest hundredth. Now we want to find the length of C. We want to find the length of the campsite to the tower, which is approximately 1502.86, or rounded to the nearest whole number, 1,503 feet. So the length of CT is 1,503 feet, which is the campsite to the tower. On to the final question in this section, which is the volume question, question 34. Shay has recently begun kickboxing and purchased training equipment as modeled below. The total weight of the bag, pole, and unfilled base is 270 pounds. The cylindrical base is 18 inches tall with a diameter of 20 inches, and the dry sand uses the base fill 95.46 pounds per cubic feet. So you gotta be careful. Our density is in feet. Our measurements in inches. So you gotta convert either inches to feet or feet to inches to get to the answer. Let's see what form they want the answer in. To the nearest pound, determine the state total weight of the training of the base filled to 85% capacity. So we first find the volume of our bag. So we know our diameter is 20 inches. That means our radius is 10 inches. So our volume is pi r squared times the height of the volume of the cylinder. So it's pi times 10 squared for the radius times 18 times the height. It's 1800 pi. 800 times pi. Use our calculator to get the answer. So 1800 times pi, second caret or exponent symbol, gives us 5,654 and 866 ten thousandths, rounded to that, cubic inches. Now, we need to continue this problem. Now we convert our volume from inches into feet. So we divide by 12 to the third power. So we divide our answer by 12, put the 12 to the third power in parentheses, do everything at a chance of an error. We get our volume in feet, be 3.27, etc., or as I wrote it on the paper, 3.27 cubic feet, volume by 12 cubed, because you divide once to 12 for the length, once by 12 for the width, and once by 12 for the height. Every volume is 3 dimensions, length, width, and height. Then we want to find our weight. So we know our density is 95.46 pounds per cubic foot. We know our weight is 3.27, so you multiply the mass, density times the volume will give you the mass, times its filling of 85%, or 0.85. Add that to the actual weight of the bag of 270. So let's plug this in. This value, so we times that by 95.46 times 0.85. Add that whole thing to 270. Try to do as much work as possible in the calculator in one step, which gives you 535.53 pounds. I'm going to round your answer to the nearest whole pounds. The weight will be 536 pounds. Okay? And that is the final answer. That's the end of part 3. If you like just me to show you other ways to do these problems, especially question 33, using different laws of trigonometry, or question 34, showing where the error of 535 pounds came from, which is also an acceptable answer. Leave in the comments below. This is Mrs. Spy, signing off, and there'll be one more video in the series, just to remind you before I sign off, which will be part 2, which will probably be published either later today or tomorrow. Then I'll start putting up August 2019, and I like to have them both up before the second week of the school year. Thank you. This is Mrs. Spy, signing off.